So just the nomenclature that we're going to use here, and this is taken directly from the Ross et al. Paper, we have a couple of things. First of all, there's the actual state, and they use L for location, but L is maybe not just be the position, it might also be the scale, rotation, etc. And then they've got an observation that's called F. And you know why it's called F? Because what they were actually tracking were faces, but just think of it as the observation. We were actually talking about them as being Z's previously. So the goal is to predict the target location based upon our last belief about where it was and our current new measurements. And in fact, what we need to be able to evaluate is this probability of the location given my last belief plus my new measurement. Now, we've done this before, right? We said that this equation was made up of two components, and we'll just copy them back up here. The two components are we'll do the purple one first. That's just our dynamics model. That says if I know where the thing was at time t minus 1, what's my belief about where it might be at time t? Now, in their work here, they used the fancy word for it is Brownian motion. For those of you who remember, that's little particles just vibrating around doing whatever they want. Another way of thinking about it is they don't have a velocity model. They basically say if something is here, in the next frame it's going to be somewhere around here and maybe rotated a little bit, and it doesn't remember anything about velocity, so it's just based upon position. But the new part that's kind of cool here is this observation model. This observation model is the probability of the observation given the state, given the location. And what they're going to do there is they're going to use that eigenbasis approximation. So what that means is I'm going to say if I can reconstruct this patch well from my basis set, that's going to be a high probability. And if I can't reconstruct it well, that's going to be a low probability. That's fundamentally the observation model that they're going to use.